Good evening, everybody.
Good evening,
Good
sir.
evening, sir. Good evening, sir. Good evening, sir. Yeah, so yesterday we started the interpretation part. So the screen is visible to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yeah, so just quickly I will revise this. So, as you all know, we got two AMI biplots after completion of AMI analysis. First biplot is based on mean performance and PC1, and second biplot is this one on the basis of G into E interaction across the PC1 and PC2. So yesterday we started with this. Yeah, so here you can see on x-axis this mean plant height, and on this y-axis you'll find this principal component 1. So then now how to interpret this? So like you can see here, this PC1 is contributing almost 50%. So that means half of the interaction variation is explained by this first principal component. So all these blue dots are the genotypes that we have evaluated. So here you can see, so this is the main axis, main line across simultaneous along the x-axis. So this is 0. So whichever the genotypes are there nearby or on this line of 0, they are less influenced by the environment. As those genotypes are less influenced by the environment, so those genotypes are called as stable genotypes across all the environments. Then those are far from that axis. Like this 0 axis, those are far from that. They are called as unstable genotype. Or you can say that as a less stable on either side, on positive as well as on negative side. Those are far from that central axis. You can call them as an unstable genotype because of they are strongly influenced by the environmental effect. Are their interaction with environment is on higher side. Then these red vectors you are seeing, some are long vectors, some are short vectors. So these vectors are there. So these vectors are representing the environments. So likewise, see E5 is having short vector that is very close to the origin. So it is very close to origin. That means it is less affected. Less variation is there. The performance of all the genotypes in that particular environment is less discriminated. So that type of environment you can call it as a stable environment. While environment like E3 and E4, so they are far from the origin and their vectors are longest vectors. Of all the 8, their vectors are longest. So you can call those as highly discriminating environment. So those kind of highly discriminating environments, those are not suitable for whole set of genotypes, but maybe it is both this kind of environments may be good for identifying the differences among the genotypes. And then the next are like even 1, 2, 6, and 8. So they are some more or other like they are clustered together. So their discriminating ability is some more or less similar. So that's why they are close to each other. And E7 is having moderate discriminating power. So that is about the environment. Then +2 -2 PC is there, na? It is written PC 49.8%. So those are those values. Yeah, and now just now we need to see genotype and environment interaction pattern. So how we can identify it? The genotype, those genotypes which are in the direction of environment vectors, those genotypes will perform better in that particular environment. So suppose like this JS335, JS720, then MUS725, and then 9305. So these 3 genotypes, right? These 3, again, these 3 are there near the E4. You can say like these 3 genotypes are adapted to E4. Likewise, here these top 4 environments are very close to each other. So this all the genotypes you can conclude like they are adapted to that 4 environments because all these 4 environments are having similar discriminating power. So likewise, 710, 731. So these are close to the origin. So their performance is, though their performance is not highest, but they are consistently performing. Because consistency is also one of the parameter. Though it is not on higher side like 80, 90, 100, but they are performing consistently across the environments. So this is overall you can say like stable environments across, those are close to that 0 axis. Then some genotypes are good in that particular environment, like 335, 725. So you can classify in that particular environments. So now if you can check 710, so almost the plant height is 65. More or less similar with MACS 1520. then KDS 1095. So all these are moderate, having moderate performance. 731 less performance than those three, but they are along that axis. So that's why, though they are moderately performing, so but they are suitable for all the environments. So we can call it as a stable and widely adapted across all the environments. So likewise, we can see.
Sir, what we can conclude about E3?
Any genotypes are there?
No, sir.
1 minute. I will increase the dimension. Just give me a minute. Just you can run AMI and increase that dimension. Make it more. Yeah. So this graph is visible.
Yes, sir.
Yes, sir.
Yeah. Yeah. So now you can tell me about E3. Any genotypes are there nearby?
No, sir.
Yes, anyone? Other? Any other members? So in which environment you will consider this? It's 979, this 9752, 11666, this, all these three.
Environment one.
E1.
Even.
E1.
And then this 139,
E3.
3 or 7?
E7. E7.
Okay. So that means for environment 3, stable genotypes are there or not? Yesterday only I told.
No, sir.
That's what. So this is what we have seen yesterday. Now we will see the next plot. Yeah. So now tell me what are the differences from plot 1?
So principal component analysis is only 25.7.
There is an interaction also.
Which Raj, see that which principal component is showing 25 and wave, and in first we saw 49.8. So whether it is there in this diagram or not.
The two major
There in
PCs
the
are
graph,
represented.
it is showing the relationship between the two principal components.
Yeah, so it is showing two things. It is first showing G into E interaction, and it is showing it uses two principal components to explain that particular G into E interaction as PC1 and PC2. Together they are explaining more than 75% of the G into E interaction. So on x-axis that is PC1 and PC2. So as PC1 is contributing 50%, so you can call that PC1 as the largest source of G into E interaction. So now in this, first we will see the genotypes. So now here, see, environments are represented by red long vectors and genotypes are represented by blue dots, plus here one extra factor is there, that dotted lines are there. So now again, if you will maximize it, we'll go to the origin. Screen is visible, Vijay. I can see my screen here.
Sir, I am not showing your screen.
It is visible only, sir.
So now as we have seen first the origin, so this is the origin. So now can anyone tell me the genotypes nearer to the origin in this case? What are the nearer genotype? that is located near to the origin.
AMS
MG680.
80. AMS also.
That is not 6, that is 518. It is not a 6. If you will zoom it, you can see that 5-18. Then next is 139. Then
2014. MS 2014 one.
More or less KDS 1063.
where is 1063?
Just near E2.
No, that is too far. I am not saying nearer to the axis. I am saying nearer to origin.
Okay, sir. Sorry.
139 is 1, 5-18 is second. Next,
MS 2014
731.
yeah, you can consider 2014 one. Then,
MAUS 731.
okay. So those here
Sir.
also same.
So excuse me, sir. What is the meaning of the circle? There is one, not circle, but it's a kind of line that is connecting the genotypes.
Yeah. I will come to it. I will come to that. So first thing is, whatever the genotypes are nearer to this center of origin, same concept what we have discussed. So that means G into E interaction is high or low?
More still. Low.
Low.
It will be low,
So
sir.
minimal interaction. So adaptability. So if interaction is minimum, what about adaptability?
Higher.
Adaptability is high.
Yeah.
More.
So minimum interaction. So adaptability will be more. And now those genotypes, those are located far from the origin. So which are those?
Maximum G into E interactions. And low
Which are
adaptable.
those genotypes?
JST 35, sir.
Sir, KDS 1063. JS 975.
The one pointed in
Yes.
circle, sir. One pointed in circle.
All those data points, those are connected with that lines. All those genotypes are unstable. Isn't it?
Yes, sir.
Yes, sir.
Because they are far from the origin. That dotted line is nothing but your representation of genotypes. In first graph, genotypes are represented by only blue dot. But here, that blue point as well as the dotted line. And whatever the genotypes are present across the, whatever the genotypes are present far from the origin. So those are having high gene, high or strong interaction, and those are specific to environments. So likewise we have seen. Then same here also for environments, depends on vectors. So likewise here you can select the genotypes based on this criteria.
Sir, dotted lines through the origin it is passing. So what it is meaning? Outer circle it is clear that is unstable, but blue dotted line from origin and few varieties are within the line.
Yeah, already we interpreted na, that 139, 518, 2014 1, 731, whatever are nearer to the origin, those are more stable.
Okay, sir. But why this blue line again? It is coming blue dotted lines
So
through origin.
first through origin it is coming, but sir, see 139. What I told, genotypes here are represented by the blue dot and dotted line. So each dotted line with dark blue point, they are representing that particular genotype. Whatever that passing through origin, so those genotypes are stable.
Okay.
So likewise, we have seen this 2014, then this 1520, 139, 518, all these are 710.
Okay. Okay, sir.
Where is the third one? So then, yeah, this is the third one. Yeah, so this is our third graph. That is y into WAS biplot. So here you can see 4 quadrants are there. 1, 2, 3, 4. Isn't it? So here first quadrant include low value with unstable genotype. Second quadrant include high but still unstable. Third column, low but stable genotypes. And in fourth column, high value with high stability. You got what I told?
Sir,
No,
please repeat once.
Yes, sir.
Please repeat once.
So there are 4 quadrants. There are 4 quadrants of this graph. As I don't know, you can see or not. There are written like 1, 2, 3, 4.
Yes, sir. Yes, sir.
So in first quadrant, some genotypes and environments are there. Some environments and genotypes are second, third, and fourth. Okay. So in first quadrants, whatever the genotypes are there, so they are having low value for that particular character and they are unstable. In second quadrant, though the performance of that genotypes are on higher side, but as far as stability is concerned, they are the unstable ones. In quadrant 3, though they are not good as far as performance is concerned, but they are stable. And in quadrant 4, the genotypes are high performing and also high in case of stability. That these fourth quadrant genotypes are ideal for a broad adaptation and you can explore them on large scale. So this is like the distribution. This is the distribution of this graph. So likewise here you can see the environments E2 2568. 5 is there. 268. So all these 3-4 environments are close to each other. And some genotypes are there. So all these genotypes are suitable for that. All these environments are suitable for that particular genotypes cultivation or evaluation. And if you can see like E4, so E4 is like E4 and here E3. As we have seen in our earlier graphs, they are having longest vector. So they are on their individual corners.
Sir, as you said, like first quadrant has low value and low stability, sir. Which value we are talking about?
After evaluation, what you did, whether you recorded any data or not, which data we give as an input, whether we have given any data.
Yes, sir.
So that only how software will evaluate on his type. Whatever we are giving on that value only.
All right, sir. I have a question here,
Yeah.
please.
Yeah.
Now, we have quadrant 1, 2, 3, and 4, and we are talking about plant height. So, to draw the conclusion here, is it the higher plant height is what is better? Now, also the scores here, the weighted average absolute scores here, is it when it is low that is better or when it is high? Because we have from 1 to 3.
It is dependent on the quadrants. That's what I'm saying. Like if it is whatever the genotypes are there in first quadrant. So you can see like environment 4, right?
Okay.
And genotype JS335. JS335 is there. In earlier graphs also we have seen JS335 is adapted to only E4. So whatever in quadrant 1, so it is low yield and unstable. Whatever in quadrant 2, they are high in performance, but they are unstable. So in quadrant 3, like we have seen this 731, that is PCA or principal component for this genotype is 0. So we have already concluded that 731 is more stable, though it is the low in performance. And in fourth, performance is high and stability is also on the higher side. So that is what this all 4 quadrants.
Hello, sir.
Yes.
If a particular genotype is shown close to a particular environment, does that mean that we can evaluate the performance and stability in that environment for that particular genotype?
That's what we are concluding. See. See here. This 335 is suitable for
environment 4.
E4. So that means whatever statement is, this JS335 is well adapted for this E4.
Okay, sir.
And the same thing we are concluding here. Same thing we are concluding here. Though it is low performance, so we are saying like it is unstable, but it may be suitable for E4.
Sir, for here AMS MB5 -18 In the previous graph, it is nearest to the environment is 7, but here it is high performing and stable. But how can we correlate that it is nearby E5? But
Sir. Now tell me. 5-18 is there. Okay. Now ask your question again.
that it is nearby E5 or E7?
You only tell. What we concluded from this graph with related to 5-18.
It should be.
Yeah, anyone?
Nearer to E5, sir.
What we concluded with respect to this 5-18.
E5, sir.
It is near or very
Low
close to zero axis.
Zero axis.
Most stable.
So it is AMSMB 5-18 is
Least affected by the environment.
that
Most
means
stable.
Most stable, sir.
just wait on your statement. Yeah, and so what is our statement on quadrant 4?
E5. Yes, sir. Okay.
So here, sir, here we are not seeing about environment. Here the
Yes, sir. High performing and high stable, it is clear because it is important for.
So in this graph, what is our main motto is we are distributing, like in D-sphere analysis, we are distributing genotypes in the different clusters. So here we are distributing the environment and genotypes based on their performance and stability. So with respect to E5, we told that E5 is the most stable environment, because it is close to the center, close to origin, or you can say like it is close to that central axis. So that's why here you can say the E5 in fourth quadrant. So it is that earlier way of interpretation is different, and this way of interpretation is different.
Okay, sir.
Hello, sir.
Madam.
In quadrant 3, no environment is there.
No.
In others, there is environment. So, what does it indicate, sir?
So here, as we have told, so likewise say this E4 is unstable. In quadrant 2, all these are unstable, but these genotypes are there. These are close to this axis, central axis, that is this central axis. So unless we can call it in means we cannot call these environments nor in 1 nor in 3. So for these genotypes, for these environments, whatever the genotypes are there, including this 71, 9305, this 725, all these are one we can say like more stable, average stability. So so this category will come under this. The genotypes will come under that type of category.
Excuse me, sir.
So as far as your environments are concerned, they are correct, either unstable or stable. They are not in that category where performance is low but stable, either low performer or high performer.
Okay, sir.
Yeah, Soundarya madam.
Sir, we are saying like it's a high performing and low performing, but this graph is against the plant height. So what the performance we are saying for the yield or for the plant height we are saying?
At present, we are we are dealing with plant height.
Plant height.
This
So
this y means plant height.
okay, sir. So plant height, actually, when we work with the cereal crop, we go with the low plant height.
Yeah, but actually when we go for stability in cereal crops, generally we didn't take plant height. We'll not never take plant height character.
Okay, sir.
As far as my experience.
Okay, sir.
Because that plant height, if suppose sorghum plant height is 300, so that is impossible.
Yes, sir.
Yeah. So in that case, we will go for this 731.
Yes, sir.
Low in performance, but more in stability.
Yeah. So it depends on the trait as well. What the trait we are going.
Trade your objective and most important your crop.
Yes, sir.
So this is WAAS, that is weighted average of absolute score. So next is we'll see the colorful diagrams. Yeah. So these are the three different diagrams. Now first is correlation between different AMI stability parameters. Second is correlation between simultaneous selection indices from different AMI stability parameters. And third one is correlation between different AMI stability parameters with their corresponding SSI. So in yesterday's file I shared, almost all full forms are covered, or anyone or anything is pending. Just once cross check. So now here, as we all know, correlation will lie between -1 to +1. And here all these AMG, ASI are the AMI stability parameters. So whatever we have seen, that this genotype is stable, that genotype is unstable, though that particular genotype is likely to be rejected on spot, something related to stability. So whatever the output we got, so these are the different stability parameters used by that function called AMI. So we'll start. First is ZA. So that is Z value of AMI, that is Zhang stability statistic. Then SIPC, that is sum of absolute value of IPC score. Then MASV, modified AMI stability value. Next, modified AMI stability index. Next, F ratio for AMI analysis, that is F test. Then EV, that is explain variance. defined by principal component. Then dz, that is Zhang distance measure. dA, that is d parameter of AMI. I think this I have already shared. Then average AMI based stability value, AMI stability index parameter. Then AMI stability index. So these all are the parameters. And now here, I will share that, madam, full form. Some I shared yesterday, but I think this ZA, SIPC are not there.
Sir, what is AMG, the first one?
So first one is AMI base stability for genotype evaluation.
Okay.
So now here you can see the different colors. Maybe color is same, but change in the intensity. Here on right side, here you can see -1 to +1. Different colors are there. So can anyone tell me why these cross marks are there on these values?
Negatively correlated, sir.
They are non-significant.
Not significant.
Yeah, exactly. So all these values here you can see in between 0 to -5.5. So whatever these colors are there, so all these values are non-significant. So that's why already cross mark will come. And whatever the significant values are there, so insignificant also, we used to say like this is significant and this is highly significant. So from this intensity of color, we can identify which is significant and which is highly significant. So easily we can distinguish it, isn't it?
Yes, sir.
So here we can say like a majority of the indices or majority of the stability parameters reveal that these indices are strongly and positively correlated. Except this last one, all are strong and positive correlated. So that means what it indicates? So it indicates that all these stability parameters will measure the stability in similar fashion. That is the interpretation of this. See, almost all the parameters are positively and strongly correlated. So it is indicating like they largely measure the stability in similar manner. All the stability parameters, they are working in same manner. Like if in our office, if 10 members are there, they are working very sincerely. So immediately we can see the progress. So it is like that.
Excuse me, sir.
Yeah, Ragini.
Sir, as some of the boxes are showing light orange color, they will also
Yeah.
be considered in strong correlation.
Yeah, if you have seen our thesis, our research papers, there are two terminologies. One is significant and second is highly significant. So can you just tell me the difference between those two? Significant and highly significant.
Sir, highly significant will be those showing maximum values for correlation.
Okay. Is
And
there any significant level?
Sir, at 0.0 so 0.01% and 0.05% if probability is higher, then it is highly significant. And if
So
0.05,
same like here, but instead of those annotations that we used to give, instead of those annotations, they made the difference of intensity of color. So the values like 54, 67, 45, 59, 66. So in these cases, you can write like these are significant. And wherever the dark color is, I think more than 9 everywhere. Almost all it is more than or equal to 9. So in those cases, you can interpret like highly significant. But overall interpretation we can make like all these stability parameters are strongly means highly means significantly and positively correlated means their working style is same. All the stability parameters are doing their work in similar manner. So what is their work? To measure the stability. So it is like that. You need to interpret each and every stability parameter, whether it is moderately significant or highly significant, or while interpreting this last line, negative non-significant, positive but non-significant. So that terminology will change based on your values.
So could you explain what is the it's in ASV, like it is in excessive, and ASV in y axis. So what is the comparison between the values? Like how can you interpret about the
Here it is not like grain yield is negatively correlated with days to 50% flowering. So means one character will decrease, one character will. It is not like that. Here the objective of this correlation is just to see the working style of these stability parameters. So that correlation pattern is different. Though that methodology is same, everything is same, but objective is different. Here you can't compare. When you will compare, when you will get the different results for each and every stability parameters. That time you can compare it. This parameter is having strong correlation, so this parameter is working properly, this parameter is not working properly. So likewise in our school, one student will score 95, second student will score 35. So at that time you can compare. If majority or if 99% are scoring 85%, so in that case, no point of comparing. So the result is like this. If you will get the different results, at that time you can compare. But here just you have to write it is moderately associated. So because almost all stability parameters are strongly and positively correlated, so you can directly conclude like their working style is same.
Okay.
Is it important, sir, for research paper to give this table?
Sir, what are
Yeah.
So what are those stability parameters?
Instead of this table, you will find this one. Here we are only giving stability parameters. In second one, we are giving parameter with SSI.
Hello, sir.
Yeah.
All right. So thank you. Assuming I don't want to do analysis for all these stability parameters, so I just want to choose one. So which of the parameter do you think is ideal for the analysis of this crop?
So AMI analysis are using all the stability parameters. Not possible. Just you will say, I want to work on any stability value, ASV. So it is combination of all those parameters.
All right, so it's just the function of the package.
Yeah, so just like while driving any vehicle, if you will put diesel, petrol, everything, you will see, but without key, how it will work? So we need everything, like we need diesel, petrol, servicing, everything.
Sir, if we will change the trait as we have done for plant height and we are doing the same analysis for some other trait, will this graph will change again?
You have analysis of number of characters you can see in your laptop and you can tell me. All the data available with you only. Observe it. If you will see any changes, just let me know. Yeah, but in this third graph, what we did, correlation between stability parameters with their corresponding simultaneous selection indices. So majoritarily in any research paper, you will find this graph. So now here we will see, as now here also in this trade, and one more thing, generally whenever we'll write paper on stability, our main character is yield. So whatever the graphs are there or whatever the parameters we estimated with AMI, with plugs, so we need to give the parameters only for yield. So I will show you one paper. Just again we will start from here only. Just give me a minute. I will show you one paper. So see here, is it visible?
Yes.
Yes, sir.
Yeah. So see here the title, that is G into E interaction and simultaneous selection by using AMI plug GG in okra. So these are the genotypes, these are the parameters. So first I have given this analysis of variance using AMI model that yesterday we have seen. Then whatever the values, so whatever the values are here, we already we have that values separately. When we perform the AMI stability package, at that time all these values were there. So see, stability parameters for yield of okra genotype. So all these stability parameter value using AMI stability. Secondly, the selection indices value for all genotypes, and third, this blub stability parameters for yield only. So all these parameters, after that this MTSI and everything. If you want, then all these graphs. So my point of explaining this is just you need to concentrate on yield. Yeah, Soundarya madam. I think you are waiting since long time. Yeah.
Yeah, sir, I think my question, someone asked my question, so I'm good. Sorry.
Okay. Yeah, I will share. Just now, because just recently, last week, we have submitted this to BMC. We are hoping for positive reply.
Excuse me, sir.
Yes, sure. Yeah.
So in this paper, you have only did analysis of fruit yield per plant. You have not considered other characters.
So see, so these are the other characters: fruit length, fruit diameter, fruit weight, number of branches, number of fruits, number of nodes. So whatever the yield and yield contributing characters, everything are there. But when you need to describe the stability parameters, you have to give only for yield.
Okay, sir. Okay. Thank you.
Rest diagrams you can keep for whatever the 7, 8, 10 characters are there. You can keep all the diagrams.
Okay, sir.
Sir, can you explain the tables in this paper, sir, please, for us?
Same thing, madam. This whatever I am explaining now, same thing is there. Same values.
Tables, sir, tables.
Whatever you have that after when you run AMI stability, we'll get values in console as well as we'll get this graph.
Okay.
So I can show you both things at a time. Wait, I have that also. I will show you 1 minute. So here you can see, like majorly, I have concentrated on yield. Yeah, so this description you are saying, na, madam?
Sir. Selection indices and that table is
Yeah,
there.
same thing, same. Here it is ASI, ASV, DA, FA. So here, yeah. So here you can see, here it is mean, and then different stability parameters are there. So you need to write the description with comparison to mean. So likewise here see, So I will make this two different, no problem, we will make it. First we'll complete the tables, we'll take tomorrow, no problem. I'll make it two different things so that we can correlate it.
Okay, sir. Thank you.
So this here you can see, 1 minute. So though that whole manuscript, I will make a table and description separately, and then that we will correlate. So that will give you a better idea. So here you can see, here also the same thing, but here, so whatever the correlation between stability parameters and their simultaneous selection index. So now, so here you can see the different stability parameters as we have seen in earlier graphs, but simultaneously you have the corresponding simultaneous selection index, and everything is same. Whatever the non-significants are there, already cross marks, and here you can see the level. So now first we will see what is the use of this AMI stability parameters. So what this AMI this stability parameters will do?
So
Yes.
tell us about which genotype is suitable across the
Yeah.
environment.
So it will tell the stability of genotypes across the environments. So now our second is simultaneous selection index. So what it will do, it will generate or it will integrate both the mean performance of that genotype and stability. It will integrate both mean performance, whatever the trait it may be, the mean performance and stability into one index. Whatever we have seen that table, that each index, under each index some values are there. So that values came from integration of mean performance and stability. Right? So that is the difference between parameter and parameter SSI. So you got it? Parameter and parameter SSI. What is the difference?
Sir, please repeat.
See, we have two things: stability parameters and their corresponding SSI. SSI means simultaneous selection index. Here many are there. That's why headings in heading it is written as indices. So stability parameter is nothing but it will quantify the stability of genotype across the whatever the environments are there, right? Then second is simultaneous selection index. So this simultaneous selection index, just now we saw that paper, different index are there and different values are there. So from where that values came? That values came after integration of both mean performance and stability. So if we will get the index with mean performance and stability, so that will be more practical. in terms of selection. And then now see the correlation. Non-significant are already cross marks, so no problem. And again, there is a difference in color intensity. Moderate correlation, 0.5 to 0.7. Then significant, up moderately significant, up to 0.7, up to 0.9. It is what you can say that is significant, and more than 0.9 it is highly significant. So whatever this total diagram for that particular, whatever the trait is, plant height, so it is showing like SSI indices. If you will cross check all these SSI indices, they are strongly aligned with their parameters. You can check the correlation of simultaneous selection indices with their respective parameters. And also, what you will say, like added advantage is that they are considering the mean performance and stability both. So that will make the selection more useful or selection more precise. We are not dealing with only stability, or we are not dealing with only mean performance. We are dealing with both. If we will get the result by considering mean performance and stability, then it is more than enough for us. It will give us a precise result. So this is the in short output of this plot.
For MGSSI, it is non-significant. So, is there any interpretation for directly for that SSI?
So, sir, see, out of 100, you can get one non-significant. So, 99 is on either side. So, one is on opposite side. So, that will not make any difference.
Okay.
Yeah. So, here one question, like what this one value is there. So, what it indicates? Yeah. Anyone? Not only in this, everywhere in correlation table, we will write 1111 diagonally.
So it means it will be always be less than 1.
No, no, no. It is fine, but I am asking what it indicates.
With the trait correlation with the same trait.
Yeah. So
Same kind of
diagonal values represent coefficient or correlation of each variable with itself. And when we'll see the correlation value of each variable with itself, it is always perfect correlation. So if whenever perfect correlation is there, the value will be always 1.
Sir, my query is that if non-significant level, how much we can take? Like here, it is only 1 non-significant.
Yeah. Then what is your question?
Question is that how much we can take consideration for non-significant out of
Yeah, you need to take if If you will not record the data correctly, then you can get total non-significant. So it depends on our data. It is not like anything that software will do. Whatever we give input, on that basis, all this analysis will come.
Hello, sir.
Yeah.
How we will check or represent the genotype in this?
No, this
Like
is not for the genotype. Here we are considering with stability parameters, as we are dealing with estimation of stability. So before that, we did this correlation. We are testing different stability parameters, whether they are working correctly or not. Here we genotypes are genotypes are not there. For that, you need to go for our normal Pearson correlation. That will give our characters. Genotypes already we did with AMI, then GG, and then BLUP. Yeah, and again one question is, why always we are representing only one side triangle? Why not full matrix in correlation?
Both side values are same, sir.
range.
Their values will be same.
Okay, so means both are mirror image of each other.
Yes, sir.
Yeah, so this is the correlation. Then the next we will see this one. So roughly anyone can tell what is this? In short, if anyone so it is like,
So ranking
is
of
it like
It is like
ranking of genotype based on the stability parameters?
Yes, sir.
yes,
Ranking
sir.
of genotypes based on mean performance
Yes.
and stability parameters.
Yeah. So just they compare whatever the table is there. From that table, they taken the values, and from that values, just they given the ranks. So just see. I will zoom it. No problem. It is clear. So just see. Suppose we'll take this 9752. So see, this is mean from second column. Yeah. So see the connection. This is one. Then from second column, stability parameters will start. So just see this particular genotype ranking for each stability parameters. So just you need to follow the color. Isn't it? You can see it?
Yes, sir. So then how we will say that which genotype is based like
Yeah,
in
that's
each
what I am.
each parameters it is different.
For that reason only I told you that tomorrow I will make it table separate and interpretation separate.
Okay,
So
sir.
from that table is connected with this slope graph. So actually all these graphs will usually make for yield character. So just see here heading also, slope graph of ranks of mean yield and simultaneous SSI. But just for understanding purpose, I made it for each and every character. So here just you can follow this color. You will get the genotype position from mean to the last selection indices. So here in first graph, only parameter, and in second graph, mean with simultaneous selection indices. So now see, I will tell one reality. Now, if you will represent, if you will write this ranking in simple table, and another person, if he will submit with this slope graph, so which paper will have the demand? Both side work is same. Efforts are same.
Slope graph.
So that is the reality of our current situation. If your representation is attractive, then you will get more demand.
Attractive
So
and
simply,
complicated.
yeah, the more complicated and attractive your graph, you will get more demand. So I should not say like that, but this is reality.
Yes.
What we have faced during our masters and PhDs, still we are facing it. So this is because if someone new person will see, he will say like, sir, what is this? But actually interpretation is very simple. If someone will ask you, explain this in 2 minutes, just you can say like, sir, this is ranking plot. It will compare mean performance with, in one graph, it will compare mean with stability parameters. And in another graph, it will compare mean with their corresponding SSI. Simple. Then, where is that heat map? Yeah. Yeah. So this heat map I told you, I think yesterday or 2 days back, I don't remember, but I think I told you. Yeah, what I told you? Anyone remembers it? If anyone.
So brighter the color, more stable is the genotype.
Sure? I'm not sure that you are correct.
Yes.
Brighter the color, lower is its performance, low stability.
So
Yes,
bright color, low rank. So more stable or less stable?
less stable.
Yeah, not
So
less.
bright
High
means it's
stability.
high stable and
If color is bright, rank will be low. If color is bright, rank will be low. The genotype will be more stable. If color is dark, rank will be on higher side. Ultimately, stability will be low.
Yes. Sir, color dark, it is showing rank is less, na 5. Low rank.
No. Below 5, see madam, dark green is there.
Brighter is more having more rank.
Dark green is more rank. Where dark is on higher side, if brighter is there, so means see this dark color, wherever it is dark, so they are considered as unstable.
Okay, sir.
Sir, can we relate this heat map graph with the slope graph?
Yeah, this ranking. So when I will give that complete now tomorrow, then we will try to integrate it. If we will get success, then it will be better. Because both interpretations are same. They are also mean with stability parameters and mean with SSI. So we will integrate both.
Sir, in earlier graph, JS335 was unstable.
Yeah.
In heat map also it is showing unstable with the brighter
Yeah.
color.
So that means your whatever you analyze, your results are correct. High rank unstable, low rank stable. So that if your results are matching, so that means your analysis is correct. Okay, so this is all everything about AMI. So one request to all, whatever analysis you did already you have submitted to me, try to interpret all these AMI graphs in short. Try to interpret in short, not like one, 2 pages, but in short. Try to interpret that so that.
So there is one more heat map graph with genotype and SSI.
Same concept you need to follow what I told. High rank
Okay.
unstable, high rank unstable, low rank stable. Yeah. And now in short I will tell how to interpret that and how to import. That one part is pending since long time for new Microsoft version. How to import text file in Excel for new people, those who are using new Microsoft. So just if you can open the blank Excel file, because I don't have, so I need to tell you orally only. Just open the Excel file, empty Excel. Okay. So go to the data tab and in that data tab, go to get data. Okay.
Yes, sir.
And from that get data, go to from text oblique CSV. Select your Excel file and click on load.
Sir, in get data there is no Excel. The text file is
No, no,
not.
no. Text, CSV oblique text, that type of option will be there, madam.
No, sir. Import data is there from web. Existing
No, no, no.
connection.
Get data, import data, click on that.
Okay, huh.
CSV oblique text file, then select your file. No, don't change anything, directly load it. So after loading, select whatever you have imported, select everything. And on somewhat on right side, one transform row to column sum like this option will be there. Click on that. It is there?
Sir, load option is showing, and then after clicking on load, it has already been transferred in
Yeah,
Excel.
it is transferred. Select whatever that transferred in Excel. Select everything. And somewhat on right side, one column, one option will be there. Load or transform. Like see the screen, like here somewhere. Transform row column, something like option. Transform row column. Raj, you can share this ribbon, this whole name screenshot to me, please. So if you will find that transform rows option, just click on that. After that, it will show like this. So go to that transform. Transform tab is there here in top. Transform tab. So from here, you can adjust this column likewise. And then after that, you can import it.
Sir, after importing, where is transform data?
So that you have to find. I don't have, sir. Please go to this transform option here somewhere. Transform row to column, something that option may be, will be there. So like see here option is text to column. So likewise option will be there.
So you are talking about sorting the data.
Huh?
You are talking about sorting the data like from A to Z.
Sorting is different thing. Transforming is different thing.
Okay, sir.
हेलो सर।
हाँ यस
सर आप वो जब असाइनमेंट 1 किया था तो उसकी वो देने वाले थे एक्सेल के कोड्स भी।
ठीक है मैं भेजता मेरे को एक बार ना सुबह व्हाट्सएप पे याद दिलाना
ठीक है सर। ओके सर।
It is coming.
No, sir.
Pawan, just share the screen. I will stop it. Just share the screen. Anyone who can share the screen, share it. I will show you. Anyone can share the screen, please. Yeah, madam. Go to Excel. That Excel file.
Sir, only translate, transpose, trend, and trim
Wait,
options.
wait. Work is going on.
So I have sent you.
Wait. Don't drive. Construction of road is in progress. Drive slowly. 1 minute. Madam, please, if you can open your Excel file.
Yes, sir. This is I open new. I have to open, sir.
No, actually, your Gmail is the Excel file is not visible.
Okay.
Sir, I have just sent you a screenshot.
If madam is having problem, some other they can share.
Sir, shall I share my screen, sir?
Yeah. No problem.
Sir, I have sent you a screenshot.
Yeah, screenshot. What is the problem now? I can understand you are showing only one option. I need different options at a time. Just have some patience. Wait. I will tell you now.
Sir, actually, visit my screen, sir. I have only one out.
Madam, go to the transform tab, madam. Beside home.
Shall I close
File
this one,
home.
sir? Yes, sir.
Now import from file text CSV. Yeah. Select any text file. Import it. Load it. Select that select whatever you have imported. Select everything.
From column 1. Or
Everything.
genotype.
No, everything. Okay.
Okay,
Enough.
sir.
Go to data.
Data. Here, text to columns.
Click on that. Here again options are different.
Can I click here, sir?
Click.
Sir,
See here. And now from here you can adjust, you can put the divider.
Then next, shall I click next, sir?
Next now. Up to this is fine. Now next I will show. So up to this everyone got what to do? Please reply fast so that madam can switch off that screen sharing.
Yes, sir.
Yeah. So now after that I will show. So now in my case, first I will import the data. So suppose this. Now directly I will come to this point from here. So now pick. Yeah. So then after that, you need to click next, and here whatever the different values, you need to divide it like this. If you will click, that lines will come. I will show you one with RBD. Or here also I can show you these values. So likewise, 1, 2, 3, 4, 5, 6, 7, whatever are there, number of. After doing this, simply next and then finish. So likewise, this division will be there. So Selvarani madam, which version you are using? Again, I think this is third. Kindly close that Power Query editor. With number ending with 4817, close that Power Query editor. Nasreen Fatima. Better to speak. There is no correlation between WhatsApp messages and what I am speaking.
Okay, sir. Thank you.
So
just can you show the process after text to column we have selected, then what we have to do? How we have to divide that different data?
You have to divide based on your input output files.
Sir, I'm not able to like select the files. Sorry, select the margins.
Just you need to click it. No need to do anything. Fix width. Next. Here you need to select. Just you need to click here. All that margins will come. And even you can
actually that data is not showing. It's a
even
blank sheet.
Sir, when you
just
are
click.
showing, sir, when you are showing this, now we are able to see only blank Excel sheet. We are not
Blank
able
sheet,
to see
sir.
what you are doing.
Share one by one screen, because I am not getting why you are getting this kind
Sir,
of error. So
only,
I
sir,
need to see your screen.
no, sir. When you are showing currently what you are doing, we are able to see only blank sheet. We are not able to see your whole screen. That's what
It is problem with me, so that's what I thought it is with you.
No, sir.
So like in phenotypic correlation, 2 columns were there. So it is working on only one column. So we have to select only one column, sir.
So now it is visible, this window.
Yes, sir.
Yes,
Or only Excel file.
No, sir. It is coming pop up from your
Okay.
selecting.
Okay. So now I will import one correlation data. So this is genotypic correlation. So up
Yes, sir.
to this, now it is not coming.
Coming, sir. It is visible.
Okay. So here fixed width, then we need to click next. Then these margins you can drag.
Okay, after clicking next. Okay.
If you want to delete, just double click on the margin will get deleted. And now next. Okay.
If we want to add one margin,
just click here.
Okay.
So likewise, it will be there. So steps are simple, but just in new Microsoft, they added more steps.
So will it work on only one column, sir, or for both the columns?
I have selected now multiple columns in place in front of you only.
In my system, only one column is being selected, and if I'm selecting,
because
So it is showing that you can work on only one column.
Share your screen.
Sir, all the 26 rows, if we are selecting, it is not transforming the data.
So at least some efforts you need to take now. All 26 means some first go for 10, 10, 6. That will come. Yeah, Raj, share your screen. These some efforts are better than typing Windows stat output, printing out the PDF file and then typing in Excel. So this I think it is better. Yeah, Raj, what happened? Madam, speak.
Excuse me, sir, after opening the file, the text file in Excel sheet, which method should I have to select? Which option, like delimited or the fixed width?
Fixed width.
Fixed.
Raj, share the screen on Google Meet.
Sir, I have same problem. Sir,
Yeah, you
when we
can
are
share.
selecting, okay, sir.
Sir, I lost the connection, sir. I joined again.
No problem. No problem. This Anjali
Sir,
madam
I've
will
shared
share
the
this.
screenshots to you, sir.
No, I told to share screen here so that I
Achha,
can
okay.
tell you. No
Okay,
problem. She already shared. So do one thing. Delete this everything. We'll start from importing data.
Sir, is there a way like just open the Excel sheet, open the file with open with thing, and then go with the Excel sheet, and then open all the files, and from there we can also come in this thing like the text file, delimited, and the fixed width. So
I will search this option, madam. If it is there, definitely
yeah,
I
it's
will
very easy
tell
for
it.
thing, I think.
Yeah. No problem. If it is there, I will tell.
Okay.
So Anjali madam, can you scroll down? In Excel file, just if you can scroll down. Just I want to see this column 2. What is there in this column 2? So now you have selected column 1, right? So now just click on this text to column. Close this. I don't know why second column. Close this, everything. Import the file again. Close this from here, queries and connection. Delete this or else simply press Ctrl N, you will get new file. Control and new Excel. Yeah, what happened? Anjali madam. So whenever we are importing the data, it will come in one column only. So here see, just delete this. Yeah, so now import here again from data. Get data. Import it. Load. Okay, select that column 1. Column 1. Now go to the data tab, I think. Text to column. Fix width. Fix width. Fix width. Next. Now here you can give the divider wherever is necessary. If you want to delete, just double click that. Double click that margin.
Sir, but what about column 2 data, sir? 0.64.
Column, so that you can adjust, somewhat efforts you can take.
Okay, sir.
Yeah, I know this generation means this era is ready to eat era, but still some efforts you can take. I am trying to solve that issue also. If we can get it ready to use, like every time ChatGPT will ask at last, ready to use this thing, ready to use. So like I am also searching it. If I'll get it, definitely I will share it with everyone. Okay. So just let me check that Vibhakar sir is there or not. I will call him. 1 minute.
Excuse me, sir.
Yeah, so regarding videos, due to some technical issues, videos are not uploaded in last 2-3 days. So by tomorrow evening, total videos, whatever pending, those will be there on website and YouTube channel.
Excuse me, sir. I have one question. Sir,
Yeah.
the question is with the related with the augmented design.
Yeah.
I tried to calculate the augmented mean. When we were doing the class, you gave the one data for augmented and one
Madam,
other.
1 minute. Hostelers, they can go. Yeah, madam, continue.
And another data set was for augmented mean, but
Okay.
when the in the assignment, we have just one data, augmented data. So I
Yeah.
tried to calculate augmented mean by myself, but I am not
How
getting.
how you calculated?
I try is it needs to be adjusted mean. So I was using some package. I tried to use some
So
package and
adjusted mean you will get whatever we did in that only you will get adjusted mean.
okay. So
Adjusted mean is there with block effect and that with block adjusted block effects. That mean is already there. Whatever we did na in that with that script you will get that.
okay, so from there I have to make a file Excel sheet with the
Yeah, from there you can import it easily from Word to Excel, no problem.
okay, and then we can do after that I should have to do with the path analysis with that data.
Yeah, if you want if you want raw mean data without any adjustment, so you can calculate like our normal mean we used to do.
Okay, sir.
So normal means what normal mean? If you have 70 genotypes, so it will be as it is, but you need to take the mean of checks as we have replicated checks.
Yes, we have
So suppose
replicated.
five
So
blocks, five checks, five blocks. So checks will be 25. So all the one check will be 5 times. So you need to take mean of all 5 times first check, then second check, then third check. You need to take mean of all checks across the blocks.
okay, and then I will do. Okay, sir.
Yeah.
I can. Yes.
Yeah, yeah,
Thank you, sir.
yeah. So tomorrow, yeah. So just to, yeah, my one question is Sunday 3 o'clock. I think is it feasible for all? Afternoon 3.
So 3 is a little bit harder. If we can go with 4, if everyone is agree, then
Okay,
4.
no problem. Four also is fine for me. Just I'm asking you people on Sunday because it is Sunday. That's why I'm asking.
Okay, sir. Okay.
It's fine, sir. Sunday is best for our those who are working, I think.
So because of why I'm taking Sunday now, because in weekends maybe I'll 1 or 2 days like I maybe because of this exams and everything. So there may be some problem. So that's why I'm not giving holiday on Sunday.
No problem, sir.
So okay. So meantime, tomorrow same time we will start with our next, that is GG biplot. We will see the representation for all 7 graphs. Meantime, you can try some short interpretation for AMI analysis. And if you will face any problem, so just reach out to me. Okay.
Okay, sir.
Sir,
Okay, guys. Yeah.
sir, once you told that through coding we can also normalize the data.
Yeah,
Is it
yeah, yeah. I forgot. I shared, I think, personally to 2, 3 members, but I forgot to tell in this session. So tomorrow starting, I will tell it.
okay, sir?
And Ajeta, I will get back to you tomorrow morning. I will tell you
Thank you, sir.
regarding your paper.
Okay, sir. Thank you.
Yeah, yeah. Okay. So tomorrow we'll meet at 6:15.
Sir, sir,
Yeah.
can you share my screen? I'm not getting that option, the queries and connection.
So you need to close that queries and connection.
So can I share my screen?
Yeah, yeah, yes. Share it. Those
Okay,
who
sir.
don't
Thank
have
you.
any queries, they can left.
Okay, sir. Thank you.
Hello, sir. Is it visible?
Yeah, open the Excel file. Yeah, load the data. Don't change here anything. Load it. Don't close. Why? Go again. Data. Get CSV. Select file. Import. Load. Select that column. Go to data tab. Text to column. Again here, right side, right. Text to column, click. Next. Here you can insert these margins by clicking inside. Just click inside, that margins will come. If you want to delete the margin, just double click on the margin. Double click. Got it?
Yes, sir.
Okay.
Thank you,
Okay.
sir.
Thank you, everyone.